Welcome to this instructional video on creating a DXF for a box. This is for your mechatronics project, and what we're looking at is creating a mechatronic kit for STEM users that's postable. So one of the first things that you're going to do is download this DXF, laser cut out and start developing the size of your box. Now in doing this I thought there was a great opportunity to show you how I would do this and some of the features I'd build into it. So what we've just seen is me taking an original box, laying it out on a bit of card and devising my sizes. And the reason we need to work out our sizes right at the start of this is so when we go into SolidWorks and we start setting up our DXF net, we know what we're drawing. Now what you'll see is in SolidWorks I started on the top plane. I started by drawing on that, I started by sketching on that plane, and what I'm just doing now is laying out some of the tabs. So the first large center point rectangle you'll see will be the bottom of the box, and what I'm doing here is I'm just adding in some corner point rectangles to be the tabs. Now when you actually laser cut this out, what you're going to see is that the sides have a return on them. So the reason for having two rectangles on each side is both sides have a return, and that way what I'm actually setting up is a way to fold the box round so it has some structural integrity. The next thing I'm going to do is I'm going to set the dimensions for the back of a box. Now I've done these off the information I'd got from my original sketch, but you can change these. And now I'm just adding what are the dimensions to the lid. The special feature you're going to see here that I'm doing is I'm clicking equals in the dimensions box and I'm making the lid equal to the back of the box. I'm going to do the same with the width of the box. And the reason I've made both the width and the length equal is so you only have to change two dimensions and the box scales. The bit I haven't done on the DXF I'm providing you is I haven't made linked dimensions for all the ancillary extra tabs. So these side tabs that fold down to provide some shielding, and then the side tabs on the base and the end tabs. You could, if you wanted to, download the SolidWorks file I provided for you and actually make all these dimensions equal, and that may make your life easier. This is something that I learned and something that I did back when I made movable walls. And what it meant was if you make dimensions driven, and they're driven either by other dimensions or by other surfaces, what happens is when you change the overall dimension on a sketch, they actually change and update. So the two things you will see me doing in this video is dimensioning tabs and dimensioning the tabs from the edges of the box. The reason I'm dimensioning the tabs from the edges of the box and not from each other is the edge of the box is defined by that original driving dimension of the length and width of the box. So irrespective of how big I make the base of the box, how wide I make it, whether it's 300mm or 500mm, the tabs and the holes for the tabs are always going to be in the same place because they're driven from the outside dimensions, not from each other. And structuring your CAD modelling in this way and thinking about your CAD modelling in this way really allows for you to have updatable parts. And part of this process, part of this project is going to be about testing, developing and fitting. So if you start to think about how and where you dimension components from within a CAD drawing, you can actually make it really easy for yourself to make multiple iterations. So again, the rectangles that are going inside that original large center point rectangle are going to be the holes in the base, and these are where the tabs are going to fit in, and the tabs that are going on the outside are actually going to be the tabs that go into it. The other thing that you're going to notice in this drawing is I'm doing everything as a construction line. The reason I'm making all these parts as construction lines is honestly because it makes it a lot easier to draw line work over them, and if I forget to turn off my original sketch, the DXF processor only picks up lines. Now what do I mean by that? What I mean by that is when you are drawing a file to save as a DXF, you are going to draw it flat on a plane and export it as file export DXF. Every mark you have on that drawing, the laser cutter or the water jet cutter is going to cut. And the reason it's going to cut them is because they are not smart machines. They are simply following the information you have given them. So a good example of this would be the diagonal lines for my center point rectangle in the center of the screen. These would come up on a DXF as part of the drawing. So if you don't want that to happen, what I recommend you do is set up your file in the way I am, and that means setting up a sketch on the top plane, laying out what honestly is going to be your construction drawing, and your construction drawing is going to be the dimensioned drawing of what you want your part to be. And then what you're going to see me do in a minute is jump out of this sketch, start a new sketch which is going to be on the same plane, so on the same front plane, and then using this sketch as essentially a framework, draw over the top of it with line work so that I have clean line work to laser cut. And working in this way of having a construction sketch with the dimensions on it that is editable and driven, and then having that drive a second sketch which sits on top of it, means that whenever I turn off the first sketch, the second sketch is there, it's neat, there's no additional sketches, and it makes it far cleaner and far easier for you to actually export it as a DXF, whether you're water jet cutting it or laser cutting it. What you're just seeing me do now is a couple of the final tabs, just working my way through, and honestly, you're looking at a little bit of my thinking as I go through. So what I'm thinking is this end of the box, it needs the tab rolling over. You'll have seen before I've put that central rectangle in it for the lid tab to close against. But obviously if this is going to fold down, what I'm going to need is I'm going to need some surface for those tabs to catch on. And I think I'm about there with this drawing. Let me just put in the last two tabs, and honestly, we're nearly at the stage where you'll see me exit this sketch, start a new sketch right on top of it, and do the very quick process of drawing over the sketch I've already done. And again, the reason for that is it means you have a far cleaner file to laser cut or water jet cut at a later date. And you're just watching me get those last few dimensions up. Unfortunately on this I forgot to set it as construction, so I'm just clicking the lines and changing them to construction for neatness. I'm going to zoom out, have a look at it, and I believe I'm about there. So what you're going to see is you're going to see me pull out those two driving dimensions, so the original dimensions that drive the size of the box in length and width. And you're just going to see me now add in a couple of additional lines, because what I'm thinking is I would like some return tabs to slide into the sides to give the box a little more rigidity. So again, just drawing these through, converting them to construction, removing anything that's actually causing conflict in the sketch. So in this case it's just becoming slightly over constrained with a couple of driven dimensions. If I just remove the element off, perfect. Now I'm going to exit the sketch, and what you'll see me do is go again to that top plane and start a new sketch. And all I'm going to do on this new sketch is draw over every line that I want to be laser cut. So you see me going along, and I'm just going around the outside perimeter. So that's one of the tabs to fold into the base, that's the second one of the tabs to fold into the base. We're going to come down here, I'm just going to draw around that tab, and you'll see me come back and edit it. But what you're watching now is what hopefully is a very quick process for you to get that really nice laser cut line that you want. Oh, made a slight mistake there. Go back out, delete the line, pick it back up at the last point. and continue. Now it's blocked in colour, you know that path is complete. What I'm just going to add in is a couple of little tab cuts here, and what these allow is for those tabs to fold in, and I'm going to start drawing around my original rectangles. This way these become cut out sections. The final thing I'm going to do is I'm going to draw across here, and then I'm going to trim the back entity. And the reason I'm going to do that is that's going to give me two tabs, trimmed and cut, that will fold into the sides and make the box even more rigid. I've gone into that first sketch, I've made it invisible, and now what I'm just doing is very quickly tracing over it to work out my laser cutting path. I've noticed my geometry is wrong on this, so what I'm actually going to do is add in a line and remove a line. This now means that the orientation of the tabs now slide into the sides, because that side on that long end side doesn't have a return. You'll see all those marks there. I'm quite happy with it. I've hidden the original sketch, and now what you can see is if I edit those dimensions and hit the traffic light button up at the top, I can edit that DXF, I can edit that laser cuttable file incredibly quickly off those two dimensions, and it means I can test multiple iterations. Now, to create the file to send out to a laser cutter, what you're going to want to do is save as a DXF, and what that's going to do is going to bring up this tab for you here. So I've selected the current view, and what I'm just doing on the screen now is zooming in, having a look around and checking I don't have any additional detail. Because these are rectangles, there really isn't going to be any additional detail, but what you might find on a couple of sections is if you have a radius, you could have some points that you need to trim. And then from there I have my file and everything's ready to go. Now that part's been laser cut out, what you'll see is you have this box here. What I've done is I've folded back these returns, including the two tabs we talked about, into the provided holes, meaning that they are locked in place, and I have this tab at the top. Now, this DXF is by no means perfect. You could probably add a little more height in this plane. You can't really add much more width, but you do have a lot of variance in the length. Depending on your product, it could be far shorter, it could equally be a little bit longer. But what you have now is a SolidWorks file that you can edit, you can modify, and this will hopefully allow you to create your own box to post out to your STEM kit at the end of this project. So thank you for watching.